Alright, number 7 says, use the graph of the function on the right to determine the intervals along the x-axis on which the derivative is positive. So if I'm looking at this, this is x, this is y. By default, this is f of x. This is my position function. Unless it has a b here, or unless it has an f prime of x here specifically, it will always be interpreted, if it's just y, as your position function. Alright, so, which the derivative is positive, we're just going to look on this position function and see when is it increasing. So when the derivative is positive, f of x is increasing. So this is an f of x graph. From here to here, I'm increasing, and then from here to here, I'm also increasing. The other parts of this position graph is where I'm decreasing. So I won't give you the question as far as when you have different functions and you're trying to compare them as far as what's doing what on certain intervals. But this is pretty much close to the same context. I will give you this on the test as far as the kind of questions to expect. So all I need to do is show the intervals of when this is occurring. So just the interval notation, you're going to say from 1 all the way to 2.5. So you can say 1 all the way to 2.5, and you're going to union with, so that's from here to here, 3.5, and this one really doesn't have an end, so you can say 3.5 to infinity. We're just going to assume that these arrows. I will be a little bit more explicit on as far as the test, as far as whether it will be an arrow or whether it will be closed as far as a closed interval goes. So 3.5 to infinity, or if you wanted to say 3.5 to about 4.5 if it was closed. And again, I will be more explicit with that on the test. So we have shown the intervals along the x-axis on which the derivative is positive simply by knowing that if the derivative is positive, f of x is increasing. And this would be your answer shown here and shown here.